Hey friends, it's Leigh Capili here joining you at API Days, New York. This is a recording, but we did this talk for a room of a bunch of different people who build large distributed systems using generative AI on things like Kubernetes clusters. And I'm joining you with my new employer today, Control Plane. So I'm principal consultant, and I'm also maintaining Flux, the Flux CD project that does cloud native continuous delivery on Kubernetes. And I'm just so stoked to be with Control Plane and working with a lot of my old coworkers from Weaveworks. We are still maintaining the Flux project and investing into it, making it more secure. And today I'm going to be talking a little bit about working to be fast and repeatable and secure with the Common Cloud Controls framework from FINOS, as well as a couple other tidbits, and of course, Flux. Now, there's a lot of different personalities or roles or different sorts of people that might be involved when you are trying to deliver a financial services application on some infrastructure. There's everyone from the engineers who are building and developing the applications, the developers. There are the kind of operations specialists who might be standing up the infrastructure itself, whether that's in the cloud or configuring a Kubernetes cluster, or maybe logging into vSphere and making some virtual machines, hopefully writing a little bit of infrastructure as code. Then you've got a bunch of other people as well who are concerned about the security and sort of regulatory stance of all of that infrastructure and the implementation. Because these systems, of course, are dealing with a lot of personally identifiable information. Now, this is a little bit of, kind of just high level information for anybody who's seeing this recording, but of course, um, we're all amongst ourselves also speaking with financial services experts. And I want to talk a little bit about kind of three segments of this problem today. One is compliance, right? And from the compliance angle, what we're really trying to do is, amongst the entire collaborative effort by which we are delivering an app that's actually going to change the experience of somebody who's maybe in a banking app or some investment portfolio, right? We want to make sure as professionals that we are meeting the regulatory needs that allow us to work with people's data in the way that we want, right? And then hopefully the way that they want. Maybe we can create a service that's valuable for, people mutually. Now, we want to be compliant, but we also want, and that's going to be managing the risk of the segment, the style of application that we're deploying. Right? But then beyond that, like, how do we actually get to implementing within our risk framework? So before we get into implementation, it's just a little bit of high level overview. Common Cloud Controls is this project, CCC. When I refer to CCC in the talk today, we are talking about an open source project from FINOS called Common Cloud Controls. And this is a rather new open source project that's got a bunch of collaborators. I'm going to show you the website, but we're actually going to be looking at a deploy preview today of pull request 735. So you can go to the Common Cloud Controls website probably in the future here. This is going to merge probably soon, but just to show you that this is something that we are actively working on, got some new bits. So Common Cloud Controls, it is a framework for providing consistent controls for compliant public cloud deployments, and specifically within the financial services sector. Right. So we're focused on cybersecurity, resiliency, and compliance controls. You can see we've got quite a nice website here, and there's a number of different organizations that are contributing. Right. So you see, of course, there's a bunch of banks here. There's also the clouds. Right. We also have a bunch of software vendors, say that provide Git or some observability needs. And then we also have a bunch of consultancies that typically implement these sorts of systems for financial services institutions. And so there's a number of organizations here with good diversity of kind of thought and stake in the problem of solving compliance in the financial services sector. And why I pulled up the deploy preview here today is, of course, this is a Git repo that you can contribute to. Here's our GitHub, you know, FINOS / common -cloud -controls. So you can go and see all of the source code, which is going to be necessary for actually interpreting and learning and then implementing and referencing the bits that are necessary to be compliant. But we also have this fun little CCC and CFI catalog. So you can come up here and you can see, okay, well, we've got controls and descriptions of what is necessary to be thinking about the risks, the potential mitigation styles that you might be considering. And right now we're thinking about object storage, RDMMS, and VPCs. We'll be using a little bit of the VPC controls today, so you can see some folks have contributed to this, and there are a bunch of features that you might get generically across, all of the major clouds. So when you use a virtual private cloud, whether or not you are using Azure or AWS, you're probably thinking about using some of these features. And so when I go and in my infrastructure as code, I implement some sort of control or some sort of intention or mitigation. I'm probably thinking about, monitoring, logging, backups, recovery. I might be using infrastructure as code. I probably would annotate my repo with that. And then similarly, there are going to be not just the features that we're thinking about, but threats and controls to actually implement, right? So you might be thinking about, hey, maybe I shouldn't expose a bunch of things to the public internet. I want to use a VPC to deal with this threat, and maybe I'm going to also enable some, encryption, or might alert on some unusual activity. So you can see this is a pretty cool catalog of the things that I need to be considering generically, regardless of what environment that I'm in. And these things would probably even apply if you are not necessarily using a public cloud service, but also using, vSphere. Cool. So that's all I'm going to say a little bit about common cloud controls, because we've got to move on to a little bit more specific things. Okay. There's a bunch of contributing organizations here. So if you are building something complicated in the space of AI models on Kubernetes or on public cloud, then I'd encourage you to get involved, get in touch with some of the people from the Common Cloud Controls project. There is also a lot of overlap with what those people are building in the field of actively developing risk and mitigation in AI. So AI brings with us a bunch of security challenges. AI security, starting just from the very beginning of the problem definition, right? We are going to be using a model, right? This is what differentiates AI from a normal web app, is that we are consuming probably something that has been produced by somebody else that's a little bit of a black box of inputs and outputs. Now, we might also be thinking about then taking a model and doing a little bit of fine tuning, right? And this is going to start to get into the issue of data privacy. If we are sending, a bunch of information over the internet or to some service that's being hosted on our VPC, what is being done with that data? Is it being reintegrated into the model? Is it being used as training? Are we having to think about if it's even crossing a network boundary, or is that model being hosted locally inside of our cluster? Once we have thought about the concerns of the model, there's also the operational concerns. How are we securing this model? Are we pinning its version? Are we going to be updating it? What is the life cycle of it? How do we know what the model is doing and how people are using it? And then how people are using it gets into end user management. Not everyone that might use our model might be having good intentions. So what sorts of behaviors are we expecting people to do? And what sorts of behaviors are explicitly things that should not be done with this particular system for its function? Now, we could be thinking about filtering some input or guardrailing the content that comes in and out of the model. This is like kind of getting into, okay, well, we're going to implement the system. We picked a couple of things. Let's go all the way down to the life cycle of what this is going to look like to operate in day 300. Right. So beyond getting the system to be secure, we need to be thinking then, okay, these are expensive pieces of infrastructure and this is an expensive workload. How do we optimize this workload so that we get what we need out of it? And so there's a bunch of different things to be thinking about when it comes to being secure and providing a secure implementation for your end users and for the people who are operating it and for your organization. And you've got this kind of triangle of increasing risk to where you get to a point where it's unacceptable. And ideally, right, the AI systems that we're interested in have specific transparency obligations. And so we want to be in a place where we are limiting the risk to what is necessary for us to innovate and build an application that is going to bring value to people in the new ways that are going to keep our financial services organization at the forefront of how folks need to manage their data and how they want to discover and work about with their finances. And so the AI governance framework is a separate open source project from FINOS that has a little bit of cross-cutting concerns and can integrate nicely with common cloud controls. And so again, there's a lot of people involved in CCC, and AI governance framework is actually even a little bit further along, right? And so if you're building right now on distributed infrastructure, trying to innovate your financial services applications with GenAI, then this is a really great resource to look at, right? So we have low-level ideas of controls and how they map to different subsets of the infrastructure that's necessary to implement an AI-ready application. And we are considering the safety of using AI responsibly. Right. And so how do we be accountable as practitioners, as system owners? And in practice, what are the real world use cases starting to emerge in the space of using AI on finance data? Right. And so go ahead and check out FINOS AI governance framework. Again, this is not a deploy preview. This is just production. And if you pop over here, you'll see that we have a catalog of risks, operational, security, um, regulatory and compliance, and then several mitigations that help us be preventative in these sorts of risk categories. And then there are some detective considerations here. Right, so one of the ones that I'll look at here is in the operational concerns. If you don't have foundation model versioning, right, then you might be starting to get some really kind of erratic behavior from your system if things are floating around because you were using a tag that was changing underneath you, right? Or in the mitigation catalog, some preventative measures that you might take to protect your organization's reputation, right? Or to constrain the kinds of behaviors that are intended and possible within a system that is using some sort of large language model would be an AI firewall, something that's examining prompts and filtering them so that things that are going into the system maybe don't involve outputting or even inputting US social security numbers or things like that. So again, a really great resource and something that I didn't even I guess I clicked into some of the details of like say the VPC features and etc. here. So what is an AI firewall, right? You can click in here and there's a really great write-up here as well as sort of some sub risks that are addressed by this particular preventative mitigation. So go check it out. This is a helpful resource. Think helps give you a full kind of high level overview of what's necessary to think about if you are trying to experiment and move forward in what's hot right now. So that's the AI readiness framework. And I guess here's the link here for folks in posterity, air-governance-framework.finos.org. Cool. So when we look at the problem of compliance and risk, right? And specifically, we're thinking about this in terms of using public cloud and and solving the needs of developers, financial organizations implementing AI on top of potentially very private systems, so that end users can get something valuable, right? So, us as SREs, as infrastructure owners, as dev teams who are responsibly owning compliance from the beginning of delivery to the end of operations, we need to be thinking about how we get there. And the OpenSSF, provides a logical compliance model. So at layer one, we are looking for frameworks that provide guidance. And at layer two, we are looking for recommendations for what sorts of controls to implement. So common cloud controls fits into kind of one and two, where we're providing guidance and then we're showing, hey, here's how you can start to mitigate things. Now, getting into three and four, we are sort of starting to say, okay, here's how we're going to do it, right? This is our policy. This is how we evaluate whether or not something is compliant. Right, so we're looking at the actual code and configuration that results in our deployed infrastructure. And then with 5 and 6, we want to make sure that for how we are evaluating our policy, that we are consistently getting to a place where only things that are within policy are actually allowed, right? And that's what allows us to satisfy our regulatory needs for this entire industry of auditors. And so you can go and actually look at this model. And Revenite has provided this on their GitHub. Right? So that's at revenite.io /SCI. Now, I've been talking a little bit, maybe too much in theory. So I think right now we've got to enter developer mode. Let's talk about getting to some real infrastructure. What does this sort of look like? What could a fast, repeatable, secure deployment of an AI application that is mitigating risks look like, right? Dev mode. I'm going to be showing you a little bit of the D2 architecture, right? Now, we're not just hacking around playing like we think we know that like we are going to create something secure. So the Flux D2 architecture. My employer here has provided a way for you to use OCI artifacts to securely deliver an application in a fast, repeatable, and secure way on top of Kubernetes. Right. So for folks, especially from the financial services orgs who've never really worked with much Kubernetes or heard about cloud native continuous delivery, we do this thing called GitOps in the project called Flux. Flux is an open source project that lets you do continuous delivery. And with what we're doing with our secure architecture using Flux, we are delivering Flux to the cluster with a Flux operator, which is a totally jargony term that just means that we get to continuously manage the installation of the continuous delivery software itself and then do some fun templating. And then everything, it isn't actually going to be fetching desired state directly from Git. So normally in GitOps, the state of our distributed computers is defined directly in Git. We start at Git, but what we are going to do is for every artifact in our mono repos, we are going to perform a software build of that artifact into almost something like a container image. Except that container image, it's not going to run a program. The container image has the configurations for our production deployments. And we are then going to sign those configurations at Salsa build level 3. And then Flux itself, in all of the clusters that we are deploying to in our fleets, is going to be doing verification of those signatures that are attested to the machine identity that built the artifacts. And so if you go over, I have a fork of the D2 repository here. Right, so you can see on my user, stealthybox /flux -d2 -ai -fleet. I have forked this from the kind of generic D2 fleet architecture here. And you'll see that if you want to understand how this repo structure is working. There is the white paper here. There's no paywalls or anything. You don't need to, submit any information. It's just truly open source. And I'm going to Control F for the word structure twice, which gives me this design description. Right, so we're not just implementing things willy-nilly here. We're following an architecture and trying to make sure that every independent artifact that's being delivered into prod is securely signed and verified. What this looks like is, say I have two clusters with a bunch of namespaces, right? Each of the configuration of these namespaces is going to own some app that might change even multiple namespaces in the cluster. How do we constrain that? We're going to make sure that the artifact for that infrastructure add-on or that front-end or back-end application is going to come from an independent OCI configuration source stored inside of, in this case, GitHub Container Registry. And so the production cluster can look at stuff that is tagged as stable, right? And then the staging cluster can be floating on something that's maybe changing a little bit more often. And then we are going to specifically update those tags and pin them as part of our continuous delivery process. So I'll show you a little bit of what this looks like in code. I pop open VS Code. I have 4 repos in my workspace. Bump the font size for you guys that are just looking at this on your television. And I have the fleet repository here. This is what is directing my clusters. So I have a clusters folder in here, and those clusters then are looking at particular tags of collections of all of the different pieces. Right, so this then looks at the tenants folder here. And the source ref is driven by an OCI repo that is put specifically into that cluster. There's also the configuration of the Flux controllers that's managed by Flux operator here. Similarly, like staging has a similar configuration, and then all of the production and staging clusters only have read-only access to the artifacts, but we actually have a continuous integration step here that runs a ephemeral cluster that updates image tags using Flux's image automations. That only happens inside of machines that are running in this case, GitHub Actions in order to update the repository's tags. And so we just spin up a little Kubernetes cluster every now and then to update tags when we release new bits of components. So the fleet repo kind of gives us that machinery, and the fleet repo is getting artifacts using a resource set, which is a Flux operator custom resource that then points to different components that are produced from the apps and the infrastructure repos. So in the infra repos, say we're managing cert manager and monitoring. And then these are also forks, right? So I'm not pointing at the canonical ones, but these are ones that have my own apps. And what we have specifically inside of D2 apps is a component called AI security architecture. And the base for this component looks at OCI manifests from Stealthybox AI security architecture manifests. And then yeah, here's that OCI repo being referenced by a customization and then reconciled to the cluster. And a service account is produced inside of this namespace as the tenant is automatically created by the fleet repo. So that service account has constrained permissions. In this case, it is modifying several namespaces, so more permissions than most apps. So there is a separate repository that contains my application, right? This is all cluster control and GitOps. This is how I decide when permissions are dropped is in apps and fleet and infra. But my actual application repo is where I'm developing. And here we have an AI chat application with some Kubernetes manifests and a bunch of security controls implemented around the app. So if I go into app chatbot, you'll see we're just running, and open source image here that we build over in the containers folder. And what were we in? Yeah, we're installing AI chat in here. That's right. Now, how do we control what happens when people are using this chatbot? One of the things that we could approach this with is with like reverse proxies. So the LLM guard deployment here is using another open source component from the Layer team called LLM Guard API. You'll notice that this is not pinned, and so we can address that in just a second here. And we implemented a little bit of a reverse proxy here to transform requests that are going directly to, say, ChatGPT, an OpenAI endpoint or a Gemini endpoint, and to stuff that request into a little bit of a JSON container that can be processed by LLM Guard. And that happens here in container proxy LLM Guard proxy pi, where you just look through the contents and then you can pass them and implement your own sort of business logic. And that allows LLM Guard API to then run some policies and then tell us if it thinks that a prompt is good or not. So this is starting to implement the technique of an AI firewall, where we are checking to see if there's prompt injection, strange languages, specially formatted numbers or information that are looking unusual inside of a prompt. And the way that the LLM Guard API does this is by downloading some lightweight local models and then executing your policy to look for a number of different kinds of threats so that you can eliminate those things early on in the execution plan. Right? That way, we're not sending denial of service attacks or some carefully crafted prompt injection over to some expensive APIs, and frankly, we just really want to limit the risk and sorts of behaviors that are necessary for, some chatbot that's running on maybe somebody's bank account. Okay. So how do we get this into the request flow, right? We're just running in, we have a chatbot app and then we have an API somewhere else. What we can use in the cloud native world is this proxy that can be configured intelligently. So in the firewall prompt YAML here, we are configuring this thing called Envoy. Envoy is an open source proxy that I can program with Lua, as well as a couple of other API first primitives. It's Envoy is used for this technology called a service mesh, but here we're just using it simply as a proxy. And so if I change my language mode over to Lua, you'll see here at the bottom, we look up inside of Kubernetes. There's a couple of DNS service discovery endpoints for our chatbot and for the control prompt. And essentially what this configuration does here is it allows us to configure request logging so that every prompt that goes through the system ends up in durable storage so that we can retain that for regulatory or compliance reasons. And then we enable the request logging, and that's on everything that's coming from the chatbot. And then we also have a response logging filter. And where's that authorization? Yeah, and then here, in order to authorize a request response flow, we also then send that request over to our reverse proxy that we implemented that is sending things to the LLM Guard API. So we are going to be looking for the LLM Guard to actually allow our request from arbitrary things to ChatGPT from some external application that's running in a different namespace. And Envoy is going to let us do that sort of network introspection in order to get in the middle of the request flow to then change the response code and say, hey, this is really not allowed. And I will show you a little bit of what that capability looks like here. So again, there's 3 cluster control repositories, and then there's our app repository, and everything is being continuously built into OCI artifacts that are signed. And here, I'm just hooked up to a kind cluster. And if I run flux get all across all namespaces, you'll see that I'm reconciling individual components that are tagged at specific digests inside of OCI. There's my tenants, my infrastructure, and my apps. Inside of my apps, I have an AI security architecture namespace that's being managed that delivers my manifests, and it's running the application. Right now I'm port forwarding, and I can send some requests. I think I had this set up already. So if I ask for something mean, like say a controversially toxic statement, like I kill AIs, and I send that over to the LLM Guard API, you'll see it says method not allowed, right? So I've said something unfortunate here, and that's just not what our system is meant for. And so I've hit a banned topic. It says, hey, that's not cool. And if you check over in the logs here, then our scanning endpoint gets hit, and a number of small models and simple techniques like using regex are run on the prompt in order to determine that it is probably pretty toxic and maybe we shouldn't allow that. But you'll see that if I send over something like this is a test of the system, that doesn't get flagged, and that's totally allowed. Right. So this is sort of the inner guts of the capability that's being built here. Now, this is a pretty complex control, right? So I really want to zoom out, right? We're like all up in developer mode here. And what's the point that we're trying to hit? So when we built this system, we wanted it to be secure, right? And in terms of the AI readiness framework, if I look across all of my repos for the tag AI readiness framework hyphen, I'm just using rip grep here, which is a faster grep written in Rust. And I want to also look in here. And sorry, friends, I'm just, I ran this command and I'm in a different directory than I was expecting. And I don't know necessarily. Okay. I'm looking for this inside of, oh, I see. I had a typo over here. There we go. That's what I'm looking for. So you'll see that I've tagged some things with some mitigation tags from the AI readiness framework. So inside of the Kubernetes manifests for AI security architecture, which is where I'm developing my app, I have error preventative 17 and error preventative 10. All right, let's go look at where I did that. So here, when I'm actually using LLM Guard, I'm saying, hey, we're implementing an AI firewall. But remember when I said that they're not pinned? Well, basically in the manifests, when this is actually packaged up as an OCI image, and before it's uploaded to the registry, we are controlling the tags by which the LLM Guard API is deployed, as well as the chatbot proxy that we use to transform, right? So this has our business logic that's actually taking the things from the chatbot and then sending it to the API. And here I'm tagging that we're pinning model versions, right? So we don't want this to be floating around on us. We want specific behavior. Similarly, if I run that same query here, but I look for CCC, yeah, that's what I want. Then you can see that in the Terraform for my GKE cluster, so I was just looking at a kind cluster, but I'm also you can see in my kube context that I'm also replatforming this entire application stack for GKE. We are referencing some common cloud controls, right? And so this is sort of where implementation starts to look like we are putting our compliance and our regulatory hat on, right? We want to zoom out from building systems, not just in a secure way, but in a secure way that can be promised and attested to. And that is a little bit of what we're going for with the full story of cloud controls, AI readiness, and managing risk in an AI application deployed to potentially lots of clusters in your infrastructure. Now, I'm just pulling up VS Code. There's one more thing here that I wanted to show you, which is that if I search for OIDC, you'll see that there's a lot of references to this key, match OIDC identity. Because in Flux, we are delivering all of these workloads as OCI artifacts. That means that our build system can sign the artifact with its identity, and it can upload that signature to Wrecker, which is a piece of the SigStore stack. That means that that our cluster can be promised that each of the artifacts that is delivered to it will then match some OIDC identity. And in this case, the subject is a specific GitHub workflow from a particular tag format, right? So this must be a tag for the push artifact workflow from the D2 AI fleet, right? And then you'll see that same sort of format played out here. So here, control plane FluxCD charts, we should have been hit from the release workflow, and again, matching a specific tag. And this is what allows us to say there are no possible artifacts that are running on this cluster once it's bootstrapped properly. And that helps prevent tampering. This means that we're going to get very expected operations, not just when we touch the system, but 300 days from now. So I think that's pretty cool. And go check out the D2 architecture. It's an implementation that is open source. You can go check out controlplane.io-fluxcd/D2 fleet, as well as our AI firewall repo. Again, I was working on a fork, because we're working on implementing some new features here, but you should see those changes like with the Terraform and with some of the manifest updates, as well as the continuous delivery stuff, moving upstream from my Stealthy Box fork into controlplane.io/AI security architecture. Now, in summary, kind of again, like what were we talking about, in the scope of everything here, right? Compliance is difficult, AI is risky, and the state of the art in continuous delivery can help us address some of these needs, right? The reason why something like Flux gives us the ability to wrangle compliance needs is because we are starting to get control over our infrastructure from the way that it's defined at the compute and network level, right, where our VPCs are, all the way through how our application utilizes that infra, right? GitOps gives you a sort of overarching like high level view of everything from where the application code is to how it's used and implemented in the constraints of potentially many infrastructure controls and features that are designed to mitigate things. And then using a compliance framework like common cloud controls can then allow us to annotate that source code at many different contexts. Now, AI is risky, and this is a totally evolving landscape. It's not going to be the same even in a month from now, right? And we want to build a readiness framework that allows organizations to make safe decisions that are responsible as we start to think about implementing these really edgy technologies into important systems that deal with private people's data, people's private data. Now, the state of the art in continuous delivery lets us do that. Here at Control Plane, we are working on a product that you can subscribe to. You can work with us as well and get the kind of expert advice of Flux maintainers. We are working to make sure that Assured Flux is Common Cloud Controls compliant and AI ready, and we're platforming our AI security architecture on top of the Flux D2 paper. Again, open source, go read it. It's like 40 pages or so. You can consume it in an afternoon while you're having lunch. So yeah, thanks so much for coming and hearing me ramble a little bit about compliance and what we're doing and why I'm excited about Flux. And yeah, thanks.